Hi, welcome to this video on using Azure Site Recovery for Azure region to Azure region replication, failover and failback using Azure Private Link and private endpoints. I wanted to jump in here and talk to you from the future and give you the kind of executive summary for what is a fairly complicated video. The main reason I created this video is that when you use private link, you have to configure Azure DNS private zones and think very carefully about DNS integration, and that requirement to think carefully definitely goes up a level when we consider multiple regions. And please check out the link below for a more generic white paper on multi-region private link DNS integration. The main takeaway here, which I reiterate at the end of the video, is that during normal conditions, when we're using private link with ASR, you can rely on the documentation that's available, rely on the auto-created Azure DNS private zones for vault access. When you fail over to the other region during a catastrophic event, and you then want to re-protect your environment, you will be using some of the same FQDNs. And customers naturally want to understand the process for failback, including doing that with private link. You will have to do an element of manual recreation of private endpoints for your vaults in the backup region, and that's best done during the runbook that you initiate to reprotect and get back to the origin region once that comes back online. So let's go into the video. Hope you enjoy it, and thanks for watching again. Azure Site Recovery, always a popular discussion with infrastructure architects working on Azure, and as a network engineer working in cloud, you're going to definitely come across it. It's all about moving virtual machines around and planning for BCDR. We're going to zoom in on a particularly network-centric area of site recovery, or ASR, today, and that is when you try and combine it with the use of private endpoints. Of course, the private endpoint story there is associated with private link. This is all about making our communication from things inside of our VNet to some PaaS services more secure. And in this example, we're focused on using these private endpoints to contact both the site recovery vault itself, a place where we replicate our virtual machines to, so we can access that data in a DR scenario, and also to the cache storage account, which is used as a middle layer between your virtual machines and their endpoint to ensure the most optimal performance from the source virtual machine. And it should be highlighted that in this video, I'm focusing on the Azure to Azure use case for ASR with private endpoints, and not the on-premises into Azure, which is also a really popular and cost-efficient way of providing BCDR for your on-premises IaaS infrastructure. To get us started and get a nice lab build up and running very quickly, I'm going to leverage this great intellectual IP by Matt Felton, a fellow Microsoft full-time employee. So he's just recently published this excellent repository of infrastructure as code related to site recovery. And no doubt behind the scenes here, there's many, many hours of work, because having personally worked with infrastructure as code and automation for ASR, it was something which I was sort of banging my head against the wall with for a while. So I'm really grateful to Matt for creating this. He saved myself and no doubt many other people lots of time, especially because to do this properly in the way in which Matt has done, there's a lot of work on the VM side scripting and the use of DSC to automate the entire end-to-end process. So I've already built out this lab here. Simply I clicked on deploy to Azure, I populated my variables, left it running for about an hour, and came back and I had my lab up and running. This is the diagram that it creates here, effectively a dual region design with a selection of virtual machines with protection turned on by default, Azure Bastion to make VM access a bit easier, that cache storage account we talked about earlier, and then you've got your vault, which you are replicating to in your failover region. And this is not using private endpoints at all. That's not the focus of Matt's lab. This is using, for example, when this VM talks to the storage account, it's going to its public front end using public IP. Of course, that traffic stays on the Microsoft backbone, but it's still using a destination public IP. Similarly, when traffic goes from a VM direct to the vault, that's also going to be using the public endpoint of the recovery services vault. So we flip back to this diagram here. This sort of alludes to what we're going to do in this demonstration, which is to enable these private endpoints and use the green path as opposed to the public path that we had before. So I've taken Matt's diagram and simplified it and put it on a whiteboard that we can draw on here. And on the left-hand side, we have that. On the right-hand side, we have the resources that get provisioned. So let's just get familiar with it. And again, Matt's automation does a nice job here because it separates out the resources into 3 resource groups. The first one inside of South Central US has got all of your live infrastructure in your primary region, like your virtual machines, your VNets, NSGs, and your disks, etc. You do get more than one virtual machine with Matt's code, but I'm just going to use one VM to prove out what we're doing here. Similarly, in the secondary region, the red region here, Central US in my case, you get kind of a placeholder resource group for the infrastructures that you would be using in a DR event, including, as we see, the replicated disks, because with Matt's code, the replication's turned on by default for 2 VMs and they start replicating and get protected straight away. Then you get a third group here, which has got your ASR components. You've got the recovery services vault here in Central US, and you've got the cache storage account inside of South Central US. Let's add a couple more lines on our diagram here just to round it out. This virtual machine here, when it talks out to both the cache storage account and the recovery services vault, it's doing that effectively as per whatever its public internet access is set up as. So if you're allowed to get out to the internet, then you're allowed to get out to these black boxes here. When you dig into the literature for ASR with private endpoints, one thing jumps out at you which you need to be aware of. When you set up these private endpoints, they need to be created before you add any items to the vault. And of course, as you can see on my right hand side, I've already got things in the vault. So let's go ahead and remove them so we can provision our private endpoints against a empty vault. Disable replication. Okay, now that my vault is empty, let's have a look at the guide here. First step for the guide is to enable the manage identity. You see that's already been done on my vault. If you need to learn more about manage identities, and just check the regular Microsoft documentation, and I think John Saville's also got a great video that explains the benefits and the attachment to the life cycle of the resource, etc. Let's create the private endpoint. I'm going to put it in the same resource group as all of my infrastructure resources in my primary region. We'll finish populating the rest of the settings as per the guide. When it comes to DNS, I'm going to leave the defaults here selected, which is I'm going to make a new Azure DNS private zone, and this will also attach it to the virtual network. If you're doing this in a production environment, you'd have to perhaps double click on this area because the private DNS zone would need a link into the VNet within which your custom DNS server was, if you're using one of those. I was going to edit out this portion of the video, but I think I'll leave it in there just for awareness and to share my own learning. And that is the deployment's failing here. And the reason for that is because private endpoints support only fresh recovery services vault. I thought we'd covered that earlier in the video, right? Where I said private endpoints can only be created for new vaults that don't have any items in the vault. It turns out that even though I deleted the items from the vault, that's not good enough. If the vault's ever had items in it, private endpoints can't be enabled. So what I'm going to do now is I'll pause the video, I'll create a fresh vault, do the required config behind the scenes, get us back to this point where I'm creating the private endpoints, and then we'll resume. Okay, we're back, and that vault's been re-provisioned now. I've got a new vault, fresh vault. My private endpoint process completed successfully. Here's my private endpoint. You see by default it gets associated with 5 of these FQDNs, as the documentation says. And if we look inside of the associated private DNS zone, we can see that the 5 separate private endpoints all get associated with FQDNs that have got this syntax in of .cus for central US being my target region here, with a unique identifier at the start, and then a type here representing kind of what they're doing in respect to the ASR microservices. So the full FQDN would be this full string here, .privatlink.siterecovery.windowsazure.com. So on our diagram, what effectively we've got here now is this virtual network. Inside of that same subnet, alongside the virtual machine, we've got these additional private endpoints. You see they've taken the IP addresses that are available. Can't use the same one as the VM, so it's slotted itself in around that. We've got an Azure DNS private zone, which has got all of those required A records in. And if we look inside of the DNS private zone itself, we can see that the process linked itself to the virtual network. So this, as part of the portal experience, this private DNS zone is linked to this virtual network here. Because I've got the required access to all of the resources that we're talking about here, I've got access to the green bit and the black bit and the red bit inside of my subscription. I've got the relevant RBAC rights. On the vault itself, when we check the establishment of the private endpoint, so you can kind of think about that as the lines that run from here over to the vault, they've been auto-approved. So these 5 lines here, they're all active now and ready to be used by our virtual machine when we try and protect it and store it inside of the new recovery services vault. We also, of course, need to remember to enable private endpoints for the storage account that we'll use for the cache. So here's that particular storage account. Okay, the private endpoint configuration for the storage account is finished deploying now. We can see the IP address 10.0.2.11. And if we place that on our diagram and update it, we've effectively got another private endpoint over here that's been instantiated inside the VNet, which we know points to our cache storage account. And we've got a second Azure DNS private zone down here linked to the virtual network with an A record pointing to the private endpoint with the FQDN of my storage account. And just to make sure that all of this private endpoint configuration is effective, if we jump on the virtual machine here, if I try and ping that FQDN for the storage account, you can see that it is being resolved to the correct internal IP address. Okay, I've deployed all of my private endpoints for the vault, for the storage account. I've tested my DNS configuration. I've made sure that all of my managed identity and permissions are correct. For example, my vault's managed identity has got access to the cache storage account. I'm using managed disks on the VM, so that's not a concern. So now it's time to go and see if we can protect this virtual machine and add it to the vault using private endpoints. And then let's have a look at the network traffic that's used and the changes that happen when we do that. Let's choose my VM here for replication. Make sure I choose the right target VNet and the correct storage account for my cache. Okay, so our replication has been enabled. And the first thing I want to call out is some private endpoint changes that happen when you enable replication for a virtual machine. If I go back to my private endpoint configuration, check that private endpoint NIC, we can see it's had some more IP addresses allocated to it. So we've now got a 2.12 and a 2.13 to add into our list here. And what we see when we inspect our private DNS zone config is we've got these 2 new A records down the bottom here with the regional code embedded for South Central US, which is our source region, whereas the 5 previous ones were for our target region. So 2 new IP addresses associated with my private endpoint NIC, 2 new FQDN A record entries in my private DNS zone. So 2 more grey lines that point to my vault via these IP addresses. You see our diagram starting to get pretty complex here, and that's one of the reasons why I created this video, is just to unpack a bit of the complexity and peel back the layers effectively and see what's going on under the hood. Okay, we know that virtual machine's been onboarded to the replication service, but let's take this one step lower down in the technical stack and let's do some captures on the actual virtual machine and see which FQDNs it's actually talking to. Here's the virtual machine in question that we've just protected. On the right hand side, here we've got Wireshark running on that virtual machine. I've set up some capture filters here prepared at the top right hand corner. I've got one filtering for any traffic going to my cache storage. I've got one that's set up to capture any traffic going to the private endpoint IP addresses associated with the source region. And then I've got one set up to filter all traffic going to private endpoints associated with the FQDN that contains Central US, which is my target. And I had this capture running for the entire time when my VM was going through the initial replication. By filtering on the IP address associated with my private endpoint for the cache storage account, we can see that, yes, the virtual machine here is sending traffic from itself to the private link address associated with the storage account. If we look at those private endpoint addresses associated with the source region, remember they were created during the process of enabling replication, not before. So they weren't created when I enabled private link on the vault. They were only created when I enabled replication for that specific VM. We can see that even though those private endpoints have been created, they haven't actually been leveraged by this virtual machine yet. If I flip my filter to the target region, then we get a lot more traffic here. And we can see that traffic is going to this specific destination from my unique identifier, ASR Central US. Remember, that's my target region. And it's got RCM in the type field here. If I scroll right to the bottom, we can see that as of now, the RCM address is the only one that's been used. And that's the IP address there, 10.0.2.8. Just to reiterate what I said there, based on the packet capture during that initial replication, when we look down our list of private endpoints IP addresses associated with the ASR private endpoint, the only one that was used according to the packet capture was this one here. Now the other ones are required, they're used for different things, but they haven't been used yet. Let's go ahead now and initiate a virtual machine failover and see how that impacts our use of private link. Okay, that failover is finished. We can now see that we've got this live virtual machine that's been migrated. So effectively the virtual machine's gone from here over to here by virtue of being reinflated from the vault. So let's imagine a scenario where this is an actual disaster and this entire region is now offline. You're recovering your virtual machines to secondary region, and for business continuity purposes, you want to keep running your IT infrastructure from these virtual machines. So we know the VM is online here in the red region and the failover is completed. Let's say we use this for a period of time and we now want to fail back. The green regions come back online. We want to reprotect and fail back. How does that work with private link? Let's make it even clearer what components here are not available. So with the region being offline, I can't access my virtual networks. Any global VNet peering that I had is now attached to an endpoint that doesn't exist. All of those private endpoints, which are NICs living in VNets in South Central US, are offline. These Azure DNS private zones that I had configured were linked to VNets over there. So even though these Azure DNS private zones are global resources, their metadata is stored in the affected region over here. So we can't make writes to them, we can't update the records. So if we think about the world from the perspective of this virtual machine here, when it thinks about contacting the vault, it's going to resolve to public IPs. So for example, if I RDP to the reinflated VM and I ping the same cache storage account that we used during the first part of this demo, you see now how it responds to public IPs. And that's because we haven't integrated Azure DNS private zones with our virtual network over here. Even if we had linked this Azure DNS private zone here to our backup DR VNet ahead of time, we would still get back an IP address here, which is not useful to us. We get back this IP address that lives in a region that's offline. And just to reiterate the problem that we have here, so if you try to do a reprotect in the current state of network infrastructure, let me show you what happens. As we see, that reprotect has failed there, and if we dig into the error message, we see we've got a problem with DNS. Effectively, what's happening here is the virtual machine is trying to contact the recovery services vault. It's looking up one of those FQDNs that we've got configured, but because of the way DNS is currently configured in the red central US region, it's getting back a public IP under the covers. We know that we've locked down our vault to allow only connections via private endpoints. Therefore, it's not going to allow access to the public endpoint. We need to fix that in order to get the reprotect working. Easiest way to do this during a DR event is to create some new private endpoints in the red region. When I get to this stage here in the private endpoint process, I am going to allow it to create a new private DNS zone over here for our red region. Okay, that private endpoint configuration is finished. We see that the private endpoint gets associated by default when you do a reprotect with all 7 of these FQDNs. Don't forget, you will also have a cache storage account here in the red region when you do the reprotect. So set up a private endpoint for that as well. Once you've done your storage endpoint and you've done your ASR endpoints, it looks something like this. You've got these 2 new zones in your backup region with what looks like a very similar config to what we had in the primary region. Similar number of private endpoint IP addresses. But just notice there's a slight difference here representing, well, my red region is using different IPs. These are different NICs, which are accessible. So again, we get those 7 private endpoints here, 5 for Central US, 2 for South Central, and we get my storage private endpoint, and the mapping looks exactly the same. Let's try that reprotect again now that we've sorted out the DNS and private endpoint reachability. Okay, so my reprotect's finished and been successful using those private endpoints. We've reprotected our virtual machine into our recovery services vault, including access via the cache storage account. Let's have a quick look on the virtual machine in terms of which private endpoints and FQDNs were being used during that reprotect process. First of all, let's check the cache storage account. So yes, when I do a filter here, I can see traffic going from my VM to the vault using the destination IP there of my private endpoint. Now let's look at traffic destined for the vault endpoint associated with Central US. So where the vault's actually located. This is where we saw traffic going to during the initial protect in the source region very earlier in the demo. Again, we see traffic going towards that. This is traffic destined for exactly the same FQDN that was used during the initial protect. Where things start to differ a little bit is if we look in the Wireshark filter here for traffic going to Vault FQDNs with the South Central US, we do see traffic destined towards it. So in summary, what we're saying there, during the reprotect process, one of these gets used, this gets used, but also one of these gets used. So it's slightly different there. I'd say one of the most pertinent points to take away from this is during the reprotect process, this one here, this FQDN, is identical to what happens in the protect operation, which means we have to plan our use of DNS very carefully, because during the reprotect process, of course, we need to return a private endpoint that is reachable and local in the red region here, which is why this approach I've laid out using a separate private DNS zone that you re-provision during the failback process works, because you effectively recreate the private endpoints, you recreate the private DNS zone, reattach it. Even if you went with the approach of trying to link this green zone here, the one that you used in the primary region, again, Azure DNS private zones are global resources, so you could link that resource to your backup region. But the point here is, part of the reprotect process is using an FQDN that would map to this private endpoint here. So with the single zone model with ASR, if you try and pre-provision this and establish this VNet link here, you would effectively be blocking that traffic because it would be destined for an IP address in the region that was offline. Let's go ahead and fail our machine back over to the source region. A failover back to South Central US is completed now. If we go back on our virtual machine, we can see that during that failover operation, the source VM was communicating with the cache storage account. It was also communicating with ASR FQDNs with the South Central US, so the ones that represent the green region there. There was no communication during that failback to any of the private endpoints that represent the red region. So there we go. We've finished our end-to-end failover, failback process, and we use private links throughout for all of our access to our recovery services vault and our cache storage accounts. The main thing I really wanted to land with this video, and the reason why I made it, was around the complexities with multi-region, which is a natural thing that will occur when you're doing failover between regions. You'll have to consider the multi-region aspect, and then viewing the world of Azure DNS private zones through that multi-region lens. So we've created documentation before that I'll link below around the general considerations you've got with private link and multi-region, but this is a site recovery specific angle. So the main takeaway here is that you'll have a private DNS zone here, which you'll use under normal conditions, and hopefully you will never have to actually do a failover. But if you do that failover during a catastrophic event, when you come to do the reprotect, you'll have to do some modification of Azure DNS private zones and re-provisioning of those private endpoints to do the reprotect and the failback. Of course, when you're back in your origin region, you can go back to using all of the infrastructure that you'd provisioned before. So thanks for watching. Hope that was useful. Again, I'll say check out the white paper below as well, which summarizes a lot of this. I appreciate it was a fairly complicated topic, and one which will definitely benefit from having a white paper plus a video walkthrough. So I'll see you in the next one.